Bromine is a brown-red liquid that evaporates readily to form a similarly colored vapor. It's part of the halogen family on the periodic table and is the third lightest halogen. Historically, it has also been used as a chemical weapon in World War I, and today we're going to make some. Remember, do not try this at home, because bromine can and will kill you. Proper ventilation is advised, like a fume hood or a respirator. Please handle it with care. Anyway, I will be making the bromine from potassium bromide and some chlorine pool tablets. I bought potassium bromide online, although you can find it in your local hardware store. We're also gonna need a source of chlorine, and I've got these tablets, which are basically calcium hypochlorite. Keep in mind that these are approximations and it's definitely not 100% stoichiometric, but I didn't want to get all of the bromine from the solution because I was going to destroy it anyway. Needless to say, if you can't do your own stoichiometry, you really shouldn't be making bromine at home. Also, excuse me for my nice backdrop being way too small, and because of it being too small, you have to look at my ugly yellow wall. Anyway, to begin the procedure, first I have to crush the chlorine tablets and add them into a 1000 ml free-necked boiling flask. After that, I dissolve some potassium bromide into water and pour it into the flask. As you can see, the color of the solution has changed, indicating that some calcium hypochlorite has already broken down into chlorine gas, which liberated some bromine. After assembling the apparatus into one of the necks, I pour in some concentrated hydrochloric acid and stopper the neck off. It's worth mentioning that all of the joints in this apparatus have been greased with sulfuric acid to make the connections airtight. Because of the presence of hydrochloric acid, the calcium hypochlorite will break down into chlorine gas, calcium chloride and water. Because chlorine is more reactive than bromine, chlorine will knock out the bromine out of the potassium bromide, making potassium chloride and bromine. After adding some more hydrochloric acid, I've cranked up the heat. Thanks to the heat, more chlorine is getting liberated and thus more bromine is produced. After a certain point, you can see bromine vapors traveling through the apparatus, and eventually they start condensing on the walls of the condenser. It's worth mentioning that I've set up a reverse funnel trap with a sodium hydroxide solution to trap any bromine vapors that make it out of the apparatus. The reverse funnel trap turns them into sodium bromide and sodium bromide. After a while, we can see some liquid bromine come over. Around an hour later, I've decided to finish the distillation and I took apart the apparatus. Some water came over with the bromine, which meant that to have pure bromine, I'm gonna have to separate it using a separate funnel. Also, some water has dissolved into the bromine, but at this point I was so sick of dealing with this chemical that I didn't even want to dry it. So I've only decided to separate it. For most people it's okay to have water on the bromine or in the bromine, but since I was going to destroy the bromine anyway, I have decided to do this last step to really cement myself as a big boy who made pure bromine. Anyway, after separating it, I've decided to destroy the bromine with a sodium hydroxide solution. Judging from the recordings, the approximate yield was 9 ml of bromine, which translates to around 40% yield. This method isn't very efficient, and I definitely didn't run the distillation for long enough. If you want better yield, you should add more hydrochloric acid, pool tablets and run the distillation longer. Although I don't recommend it, since excess hydrochloric acid and chlorine pool tablets will produce toxic chlorine gas, and also since bromine is extremely dangerous. The only accident I've had during the procedure was when my goggles slipped a little and some bromine vapor got into my eyes, and I had to leave the area to wash them. Well, it wasn't painful because the vapor wasn't concentrated, but needless to say, it was extremely unpleasant. Anyway, if you want to attempt this procedure, please be careful, since it's extremely dangerous, and if bromine were to spill everywhere, and you wouldn't be able to neutralize it with sodium thiosulfate or sodium hydroxide, it, needless to say, would be a giant disaster, and you would have to evacuate the area of nearby pets, family members and bystanders. Thanks for watching, remember to subscribe for more.